I'm Kamala Gunwadana. I'm a fellow representative of the IESL Council this year, and I'm chairing this chairing subcommittee of Civil Engineering Sectional Committee. Actually, today this webinar is a very timely, appropriate topic. We are doing this with Dr. Laxit Pradeep, and you will experience very important facts through this webinar. Its target here is that through this modern approach to give the benefits to everyone who involved in this construction process, maintaining all the intended benefits expected from a concrete slab, and that will be accomplished one beyond the expected levels. It's a great concept. So very briefly, I will introduce about the resource person today, because he's not a stranger now. He has shared a lot of his expertise, knowledge with our members. So if I simply mention about his academic career, he's a product from University of Ruhuna and has excelled his higher education up to a point that where he has achieved a doctorate today. I mean, for some time now. He's presently a senior lecturer of the Department of Civil Engineering, University of Open University, Sri Lanka. He's the CEO of Eco International Engineering Consultants Private Limited, where mostly high-rise buildings and infrastructure, relevant structures, designing are being done with that. So, and they are always trying to move with cost-effective designs and construction methodology and minimize the construction costs. So with that remark, without further ado, I invite Engineer Dr. Laxit Pradeep to take over the Zoom stage and to proceed. Over to you. Thank you.
Thank you. Thank you very much for the kind introductions. I think third, fourth times you are introducing to this session. Basically, today the lecture is to discuss about the composite slabs. So I think most of our engineers are now familiar with these composite structures, and I think I got to know that some of the normal people also joined with us today. My idea is to actually present some things relevant to the industry nowadays, because far as we know that industry is facing a lot of problems. One thing is the material price escalation. The second one is the time taken for the projects. And the third one is the barriers, because in mostly the urban areas, so the construction issues are coming right now. For example, the dust, noise, and also sometimes the waste material taken out from the site. Those are become very critical in the suburb area construction. So for that kind of thing, the composite steel structures is very much appropriate. And mostly the first questions people ask is, what is the durability of steel structure? I think I would say, you should not worry about that, because we do have now the structural steel, which may have in the lifetimes over the whatever 75, 100, or even beyond that. Then the second questions come is the cost. I would say, even if someone interested, we can share it now, because in this kind of project, simply, so the overall 60% of the construction material has to be purchased in the pre-construction stages, because mostly this kind of buildings we fabricated in the different site, different yard or somewhere else, and we just bring to the site and we put the nut and bolts. I think if someone have questions also, you can put into the chat box. So while I am doing the lecture, so I may able to answer the few questions. Then the issue, the people, because mostly the design engineers and also the engineering industry is a little bit towards to the traditional way of looking at it. For example, we still deal with the concrete masonry structures where we used to have few years back, let's say 2-3 decades back, and the innovations and also the now the compatibility for the structures installations become critical nowadays. I believe this is one of the project I selected to explain today, and we in our company actually we were able to complete I think couple of projects over the last 2-3 years with a short period. For example, before entering to the presentation, I would say, for example, 6-story building, to complete the entire project, you might need at least 12 months or 24 months in between. It's depend on the project. But if you do the steel building, you can do it within the 5 months. So these are not an arbitrary value I'm just telling to you. So we have done such kind of project. So the within 5 to 6 months, we may able to complete the project. So with this, I think in having considering the present Sri Lankan situation, you should mostly focus on the construction time. So if some clients, let's say they have started thinking about to have a project, maybe last year, and still he is continuing, I think the material price has escalated more than 4-5 times. But if someone invested on this composite steel building, they only have an issue on the labor, because as I said to you, 60 to 70% of the material can be purchased initially. This is the advantages we do have. Okay, so then what is this the composite slab? The composite slab is you basically work with the 2 different structural material. Even reinforced concrete is a composite structure, but here the difference is you use as a steel, structural steel for the structure, for the building. Let's say it can be the building, maybe the bridge, or else any type of structure you are considered. The composite slab you can have in 2 different ways. One thing with the profile sheet decking, steel decking. So we will be talking on that. And another one is in situ reinforcement concrete. Having considered, I have written here the different. The profile steel decking is given a chance to have an additional, actions on the slab. But the in situ reinforcement, what you have to do is you have to prop it. It's like a normal concrete, but it will be going through the beam with the shear stud and all. So we will discuss a little bit of the design part as well today, right? So this is what basically we do. So, but in mostly in Sri Lankan case, I believe this part, the profile steel decking are very prominent. The reason is putting up to the steel reinforced slab will not take much time. Once you install the decking, after that you put the reinforcement. Next day you are able to do the concreting. Maybe I think we don't recommend the manual one, but anyway, ready mix concrete you can put it. But in situ concrete, the issue is you have to give a lot of effort to put the support under the slab. Here you don't find the decking sheet. For example, I think we have a slide on that. So here it takes some more times. That's the issue. However, having considering these 2, I believe here the process is quick. Here it takes a little bit of time. It's a time spent in work, but maybe a little bit of cheaper comparatively the decking profile. However, we are not encouraged to do the second one. We mostly go with the steel decking one. So then this is the project what I was talking to you, but today it's different. What you can have is in a steel composite slab. Unlikely the reinforced concrete, you need to have a transfer floors, etc. Because let's say your ground floor is having the car park or whatever, basement or anything else, which need a high span comparatively, in other floors, you can easily manage here with the long span. This is why, for example, this project, what we have done is, if you simply see the front side, right? So this distance, sorry, we were able to manage this distance. And actually, I will not share the footprint, but we don't have any single intermediate internal columns in this building as well, because this is planning for the class, tuition class. So because of that, we were able to avoid all the internal column for this building. This is, the floor is something like 7,500 square feet, right? So 6-story. Then ideally, this kind of investment are much suited for the large scale span over all the floors. So everyone would like to have, because architecturally, every architect wanted to have a long span without disturbing the space. So when the challenges come in, I think the concrete, you might limit it probably the 7 meters to maximum 9 meters somewhere else, right? So in the transport, you might go a little bit, but still you may still able to go for, like, now I remember this is like a 14 meters, and even the highest span I have done in Sri Lanka is almost like a 18 meter. But it is, I don't think it's possible to. Sorry, I think let me share quickly the presentation. I don't know what's happened. Give me 1 minute, so just to share the presentation. Okay. So I was just talking about the architectural aspects, right? So this is economical. Mostly people will talk about the economical, this feasibility of having the steel structure. I think if you do the proper analysis, if you do the proper calculation, so still I think you can justify that within the range of the reinforced concrete, you may able to done it. The mostly people will not take in the ROI, return of the investment, which time taken over the traditional reinforced concrete, that you have to take into account. For example, if someone takes to complete the project for the, I think Netuli, you have to mute yourself. Right. So then what I'm saying is usually any investors or any projects, you will look at the ROI, return of the investment. Once you do the return of the investment, you should take in one parameter, that the time taken for the project. So the reinforced concrete, if it is taken for the 2 years, but anyway, if the steel building is taken 4 to 5 months, that aspect has to be counted in the project, in the viability of the project, which calculate for the return of the investment. Okay, so I was just talking about the architecture, usually what architect prefer to have it. So architect usually prefer to have the longer span, thinner slab, more slender columns, smaller columns, and the more generous opportunity for the design. So we have to give the flexibility of that. This is the early stage of our project. You can see, you won't see any element, any internal elements in this building, which architect prefer to have. So then they can have any own designs, any own arrangement within the building. And the good part of it, if you design for this imposed load, in any case of which can be accepted, you have a chance to change the building layout as well. For example, the purpose of use can be easily changed based on the client requirement. I don't want to much talk about this one. this building has another, for example, important fact that when you do the composite steel structures, usually you will have, now for example, what you need reinforced concrete, probably beam depth is, let's say 750, you could manage that, that is within the 350 millimeter in a steel. I would say half or nearly higher. Then calculate, for example, if you go for the 6-story building, if you save each floor by 0.3, so then the 0.3 into 6 in it is 1.8 meters. So the building height can be saved, which you need the clear height of the building over the reinforced concrete. This is one calculation the attractive one. So then the building, probably if you have a 20-30 story building, you can have an additional floor within the same building if you design again the reinforced concrete. So the steel has a higher chance to have a less beam depth and also the small scale column use. And we were used to have the strength classes of steel is 275, but nowadays we have the S 435. That is almost not double, but like a 1.5 times. The structural strength of the concrete, the steel elements, become more innovative and more attractive right now because having these strength classes of the 407. So all my projects we are doing with the high strength classes. The reason is steel are usually coming with the ton prices. Though the class is the class is different little bit, still the price won't be much change. In Sri Lanka, you could easily find any class of the steel element. Let us see the functionality of the steel structure using the principle of the reinforcement in which concrete protects against the steel is corrosion and the fire. The service now these are even you should consider in the steel as well. So the corrosions, the fire resistance, and all these things. People might ask, this is a different topic we should talk. A fire, how the fire resistance works within the steel structure. There are certain paints, there are certain ways to do that, right? As mentioned in the concrete, you can design it based on the Eurocode, what it says. So this is how the assembly is working, right? I will quickly go because I don't want to spend more than 1 hour for the entire lecture with the questions. This is how in our project, almost done this project, you can have it with a great accuracy because we do all the fabrications with the fabrication drawing at the different yard and you bring to the site and you settle it off. Here, the accuracy, alignment, and everything will be perfect. Not unlike the concrete, the settlements, sometimes, the issue of shuttering, that won't experience here misalignment at all. Right? What is this composite components of the composite slab? So if this is the one, actually, you can see here, right? I will show a couple of video at the end, if possible, if there is a time, right? So this is the main beam that you are putting into the building. So we call it as a primary beam, right? So usually what will happen is if you do have the columns like this, so the primary beams work like this. So then after that, you put the secondary beam like this just to support for the reinforcement and also the decking sheet, right? So after that, you will have this shear stud. So shear stud is the one main contributions for the composite beam that we will talk in the design stage right now to balance in between the two panels. Here we put the shear stud and I will show you how to install it and all these things through the video. After that, you will put the reinforcement top of that. As you know, in a shear stress strain block, the same like concrete, right? Same like concrete, you have the concrete top reinforcement and the decking below. So we will discuss right? So I will show you first how to install the beam. So this beam depth is almost 900 millimeter. So we do have a span somewhere here to here is almost 14 meter, right? So this is the advantages that you, because concrete you will only allow 7.5 to let's say 10. So almost double span you can have it within the 900 millimeter. That is the same one you use, even 7.5 meter you need somewhere around 9. So if you, I think, unable to design with the concrete because you may not be able to satisfy the mostly unless or otherwise it's a transfer flow, the deflection in the concrete. But concrete, of course, the steel, of course, you can have a lot of option, shear stud and sorry, the shear plates, etc., stiffener plates. Then you can have your own design to advocate to have a required movement and the shear. Right. So this is the good part of it. I told to you the continuous beam you can have a L over D 25 to 28, which concrete you allow 10, 12 to 15. Here the simply support you can go up to the 22. That this is the steel beam, steel structure you may have. I would proudly say this is the unique project I haven't seen in Sri Lanka. You can simply see this project. The openings are here. Openings are here. So what we have done is, in this kind of project, we work with the closely work with the MEP engineers, the fire and electrical, right? So I think here it's all covered, MEP, when I was saying, right? All these three, the mechanical, electrical and the plumbing, we closely work together and we do 100% layout and the designs initial stage. After that, having discussion with them, we have a chance to keep in the provision for the ACs and other service line within the B. So then you will not lose any clear height again. Now, usually what will happen in any project, especially concrete, after that you have to lay a lot of cables and also the pipeline, AC lines, duct line, etc. I would say I haven't seen in Sri Lanka. Maybe there are, but this is the unique project that we have incorporate all the service line within the web of the beam. It is quite challenging and quite difficult to do that, right? However, we managed to do with this regard, we may able to keep the clear height top of the slab up to the bottom of the beam. So this beam height will be used for any purpose of the client. I don't know, it's depend on the huge audience that you wanted to maintain, etc. This is how it's designed, the effective, exactly like a concrete, but only thing is you should be able to understand the behavior. So effective with how do you calculate it, L over 8, right? I will limit this one to basic introduction because I don't want to go much in the detail, right? Here the T, how the H beam, how it is, the E is eccentricity from the beam. Everything is very clear. I think the design of the steel composite structures are much easier comparatively the concrete. This is what my feeling. But however, you should be able to understand the integrity of the structure and how it works under the lateral loading and the permanent loading. There are so many software like S-Frame, Tesla, different kind of softwares available for analysis. Unlikely if you use the SAP 2000, whatever the SAP or the Procon, they are a general software which you allow to do the analysis. But there are certain softwares that once you do the design, the model and analysis, and after that, the software itself allow to produce the 100% drawing. For example, I would say, but however, I would not recommend the initial stage for use such a software because the design engineer should have to have understanding how the software is working. Otherwise, its software is a black box that's give the input, and other way it's give the set of the drawing. Even though you do the mistake, he has a way to come out. after training of this software so long, you will have a confidence to do that. Actually, now it, for example, if you in theoretically, you can do entire building model within a day, probably with the 100% of the drawing, which you usually, I think most of our structural engineers have an issue of producing the drawing, then the analysis. The software, like a software called Tesla Advanced Steel, those software will allow us to make a 100% fabricated drawing by a second. You just need to push the button, so 100% the drawing will be produced. The slab, now I think today's topic is talking about the slab. Why I am saying the slab is effective and in terms of the cost, and also in terms of the material, because we are doing, if we can reduce the material usage within the building, so building automatically considered as a sustainable structure. That we have to look for as engineers, because today entire world is facing the problems of the natural resources and the price escalation and carbon dioxide emissions. You know, a lot of issues we are talking right now. If such, we should be able, as an engineers, we should be able to find it out the feasible solution, especially the economical solution with low usage of the material. That I always highlight. You can have an economical design, but always make sure that the economical design will support the less use of material as well. So that always in our ends to be, even our country is developing, we have a responsibility on that. In slab, I would say, I think I don't want to much talk about these the equation and everything. It's very clear. I will give you, for example, this thickness. You can have this thickness, for example, whatever the distance you consider, 120 millimeter slab thickness, including the decking sheet. And you know, even decking profile has, you know, different decking profiles are there like this. Again, somewhere here, because usually this decking, the difference in between the profile is maybe 20 millimeter. It can be vary even the 10 millimeter. There are so many type of one. So then after that, it's still the radius. Even if the spans are lower, sometimes we may able to do with the 90 millimeter thickness. 90 millimeter is almost 2.5, let's say, 3.5 inches. But if you do the concrete with the structure, you at least required, I'm just talking about the high span, you need 200 millimeter, which you may able to have probably the 100 millimeter. The concrete requirements for the slab is almost 50%. And then the question is coming the reinforcement. I will just go through the designs on this later. But before that, I just wanted to convince you that why this is economical, why this is user friendly, and why this is so fast. The reinforcement you can have usually, I'm you know, wrong to say this one, but anyway, in any span, T8, or else you can say it Y, T8 at probably you can manage 200 millimeter center to center both ways. This might be different actually, even basic on the design, sometimes it might be T10 or like that. However, look at how many, now for example, you know how many bars for the T10, T8, 415 bars per ton. T10, usually 278, up 270 to 278 per ton. If you go with the concrete, T10 at 200 center to center, but usually it's coming more than that 150, and T8 on the same space, you look at, you almost say another 40% of the steel reinforcement required for the composite slab, right? Usually in my many projects, what we are doing is we don't go beyond T8. This is the most economical design. So the main reinforcement, the main directions T8 at 200 usually comes. In other direction, T8 comes in 250 or 300, because we control the deflection by the secondary beam. You can see, I will here, this is the primary beam, this is the primary beam, this is the secondary beam, right? So then we don't want to control the deflection through the composite slab. That is quite difficult. So then through the secondary beam layout, we can control the deflection at all. So after that, we only need this segment to bear up the shear and also the bending moment within a section. Right. We will quickly go. So I will spend 1 minute here. This is the stress strain block for the composite slab. Here you will see this is the main beam, right? Fully support below, and above the you have this is concrete plus the reinforcement FS steel, and also you can see another steel support here. That is the decking. There is a decking sheets comes here that also support to the stress. That's why there are two type of steel, FSN and FA1 is working here. So to the balance this one, this is FS gamma S. So the steel coming, right? So this is the stress block, little bit of different than the concrete. The concrete, of course, you know that the top part is compression and the bottom tension. Tension will take care of the bottom steel, and the top probably taken care of the tension steel in tension and the concrete, sorry, steel in the compression and the concrete concrete in the compression. This is how it's work. But beyond that, the steel is a different. So that's why you can only see here we put only the hogging, I mean the compression reinforcement to the top. You don't need to have bottom reinforcement, because to act on the bottom, the tension part, we do have this steel secondary beam. I think, I'm not sure everyone is remember this stress strain. So this is how it works. So we simply take it as a simply supported structures in the steel. There are certain ways of doing it. You can design either continuous or the simply supported, but what in many cases, the frame analysis, what we preferred is to have a simply supported. So beyond that, you can see this is how the effective L's and how you calculate the bending moments here, which generate. So I will leave you to see, study on that. But I don't think you have any complexity, very simple equations. And you do the completely the steel element classification. Similarly, you have to see whether plastic, etc., elastic, right? The section classification, you have to do it. I will not spend time on this. So this is how it works. It's 100%. If it is a pure bend in this one, so it's completely like, you remember Eurocode 5.2, right? So you can use this one. It's completely like the normal steel design. However, now here 235 is using, but we now have a 435 in Sri Lanka available for construction. This is how it's work in a movement capacity according to the price stress beam. I don't think so this part is tension. Tension is, I think, if someone didn't get in the past, the tension parts completely taken care of, the secondary beams available in the bottom, maybe the primary, it's depend on the direction that you are putting it up. And the top part compression will taken care of by the concrete here. This is the concrete part. So that's what I say, that you need a small amount of, the thickness of the concrete is much lesser. Here you see the FY, that FY is the decking sheet support, and the top reinforcement is there in the top. So this is how it's work. Very simple arrangement. And another thing is, there are certain softwares with the suppliers, decking suppliers, because once you give the span, so they have a softwares, for example, in the local suppliers, you can name any suppliers, decking supplier. They will generate this the requirements through their softwares. So the decking thickness, 0.7 is available in Sri Lanka, 0.7 millimeter, then mostly 7.5 millimeter available, but very rarely. Beyond that, 1 millimeter is available. Usually we prefer to have, and other thing is, when you do the construction, we have a two way of design is prop construction, unprop condition construction, which you put the ready mix. Based on that also you can design the thickness. If it is usually unprop, the thickness of the slab decking sheet will be a little bit of higher. These are movement resistant. I think the equations This is how you calculate whether it's the plastic capacity of the movement. Very easy. The equations are here. So the Fs you can calculate it, the top reinforcement here, right? So the ZW is, I think, the TW, the thickness of the web, and the Fy is the steel grade. So total Fy, the P and neutral axis can be calculated, the plastic neutral axis through the section. After that, you may able to calculate the movement capacity. Absolutely similar, likely normal steel design. However, you need to consider the concrete part, which is shown in above. This is how it's work, because sometimes the neutral axis within the slab, neutral axis within the planche, neutral axis within the web. But these conditions very rarely come, I would say. This condition very rarely come, but these two work. But if you could put the neutral axis somewhere there, so you can have an economical solution. However, and that times entire tension part should be able to taken care of by the secondary beam or the primary beam. Right. So the shear resistance is very easy. Fy times AV times 3 gamma m. AV is the shear strength of the bare steel element. I'm sure this is 1.6 times Fy times AV in the 5950 the code. Now the Euro code, a little bit of given a chance, reduce this parameter. The reason is, I would say, because when you have a composite slabs, the concrete is getting involved on this. So the combination, the safety factor has been a little bit of lower down. And this is movement resistant with the high shear, right? I don't think I should explain this design part. This is there are two ways of designing it, the crack sections and the uncracked sections. So this will be basically doing through the stiffness. This is nothing to do with the strength or in anything else. You can see it is the elastic module and the second movement of inertia that play how it's work. This the movement we call the shear bending interactions diagram. It's exactly similar what you do, right? So this is a kind of lateral torsion buckling. However, this will be all right in the many cases if you monolithically cast with the shear stud. If you separately cast with the panels, this will be a critical. Otherwise, it won't be a big issue. So shear connections, how it's happened. Serviceability cracking of this is what I was saying to you. You have to make sure that in the continuous beam, the concrete cracking is mainly due to the tensile resistance in the hogging moment region. This cracking is prevented by the limiting of the bar space and the diameter. The decking sheet, I will give a brief introduction. This is how it will install. Always we were, the lap, we at least go for the 2 span, 1, 2. You will not cut in the decking sheet in each and every interval. At least you should try with to the 2 span base, 2 or 3. It's depend on the availability. Beyond that, you can control the deflection and everything. This is how I think this is the last floor. It's a roof coming it up, right? This is how after you lay in the decking sheet, this is the floor where you have put up the entire decking sheet requirement. This is the decking profile you can see here, what I was telling to you, right? So the in between these gap, it can be go up to the 1 inch to 2 inch. So if you have 120 millimeter, so even here, you will have a lesser than the one you consider for the concrete volume. Right. So this is the edge form in any construction, any steel design. You should have to have this edge form. Sometimes people have a different kind of arrangement here, but my suggestion is to have a perfect edge form. Then the shear stud are tied up with these section together. Then you won't have any shear failures at the edge. Right. This is how edge forms are working in the composite slab. Right. Then this is one of the most important one, a decking fasteners. Some people are avoiding putting these decking fasteners because of shear stud you put into the similar flow, then that will be tied up together. However, before you put the shear stud, the deck, once you laid the decking sheet, when you walk or when you keep some weights, let's say the reinforcement or something else, then there is a possibility of getting the deflector. To prevent this one, we use this decking sheet before you install the shear stud. So this is the shear stud, the height, everything you can see here. The total height almost 120 millimeter. So the bent up bar. So the bar is working like this, right? And this is how it's work. I will tell you what is this white part. So that is collar you insert in the shear stud, and after that you put into the electric car that will be connected to the main beam. This is welding shear stud using the arc method, right? I will show you a video quickly how it's installed. So then the reinforcement are put in like this, right? To control it over. This is how once you laid the reinforcement, this is how it's happened. You can see usually, let me show it very clearly to you. These are the primary beam, right? You can see here, you can see here. This is how the secondary beams are. These are the secondary beams. Somewhere here also it should be. Then once you put this one, the entire structure will be designs again the shorter span. I don't think we should talk on that line. Everyone's know that. So the minimum requirements of the reinforcement can be calculated. So once you put this one, you may able to lay it irrespective the shear stud requirement. After that, you put these shear the reinforcement arrangement to tie it up with the floor reinforcement layout. I think very easy construction. This is how it's happened after you put it, right? You can see here the shear stud and everything. Shear stud and everything. So for this, I think almost I have taken 45 minutes. So if you do have any questions, you just direct to this email. We will try to help you out in the process of designing, etc. Let me quickly show this is I don't know you can see it or not. This is how the beams launch in will take place. Sorry about the safety requirement. The people will not listen to us always. However, you may able to see this is a 900 millimeter span beam, right? So this is how the launching are taking place, right? This is what, how, I mean, this is really, I mean, we were completely taken out the team who erected. I just wanted to show how the people are unsafely practicing it, right? So there are certain professional team. Actually, I am not a fabricator for this one, that has been given to the third party. So I notice it out. What I wanted to show off here is this beam is 9 meter and it has a span of 14 meter, that you may easily have a large span within the building. So I told you, this is how the shear stud are installed in the composite. You can see that the white color, that will be you put inside, you look at the side, and after that, because huge heats are coming out to control over it, this is how the shear stud is installed, and after that you go to the point. I will show you how to this is how the shear stud are installing. You can see it off, right? Once you install like that, after, let's see another one quickly. You may see this white color, right? So after that you get it rid of it. Okay, so with this I would like to conclude the presentations, and if you do have any questions, I am ready to answer on it. I don't see any questions on the chat box. Ms. Kamala?
No questions, no? Chat box, they have not put any questions. We can ask the audience if they have any questions right now.
Yeah, quickly they can on mic and ask, yes.
Since there are no questions, I don't know whether you all can't unmute yourself. Oh. You can raise hand if someone is having any question. Otherwise, we will wind up. Is it okay, Dr. Pradeep?
Yes, of course, yeah.
Yeah. No raised hand. So I think yeah, we will wind up the session. So it's very excellent presentation and a valuable lecture, Dr. Aksiri. So I appreciate your time taken from out of your leisure time, your valuable time taken for this to share your expertise, knowledge with our participants. And thanks a lot for that. And it's a very important, very valuable lecture for actually today's context also. So I hope our participants have absorbed whatever you wanted to, the message given, right? So I will not take much time, but I appreciate our chairman of the Civil Engineering Sectional Committee, his guidance and his support to conduct this sort of webinars. So I thank Professor Jayasinghe, and I thank our Honorable our Secretary of the Civil Engineering Sectional Committee and our team. So with that, also I want to extend my sincere thanks to the IT team of the IESL. Unfortunately, today that recording chamber has some problems, so first time I am doing it. So thank you for the opportunity. Who else? So finally, I think I will not drag the time because it's power cut and all. I thank you all for the participation, and without all the participants, thanks a lot for your participation. And without you, of course, there won't be a webinar. So thank you. Hope you enjoyed the session and you absorbed whatever Dr. Laksit was trying to give you, the message and the details, right? Thank you.
Thank you.
Expecting many more.
There is one question actually, the elevated highway, is that the composite? Yes, I mean, composite is not limited for any buildings. If you see, I mean, the composite, what I have seen is the higher technology available in the Korea. So if you see the YouTube, they were right now starting using the column beam joint even through the composite structure. That's how they are trying to make their structures construction time fast. I would say I think even in the probably right now I have done a couple of houses also, like 2-story houses. The cost analysis in my gut feeling is even it's far with the normal reinforced concrete. Only issue comes with the small scale building. You have to give a lot of architectural requirements, such as a drop openings, etc. In that cases, the concrete is a smooth material that you can put it and get hardened at the side. Unless steel has to do, if they are. I'm sure with having these construction issues in Sri Lanka, the price escalation, everything, every engineer should look at in a new perspective of doing the construction industry. Otherwise, if we are trying, because we have a challenges now, if the challenges are there, if we are keep continuing through the traditional way, I think we are going to fail in the entire industry. We should look at the opportunities and we should look at the innovative way to do that. Thank you. Thank you for that. Actually, the Professor Jayasinghe invite me, Professor then the sectional committee, Professor Ranjit Dizanak and everyone, and especially the compere. Thank you very much, everyone, and also the participant who has given their contributions to this event.
Thank you. Good night.